Hello everyone. In this session we are going to discuss what are the important observations of a losses in a transformer. So for a different values of voltages and frequencies, what are the changes in hysteresis losses and eddy current losses followed by iron losses. So we all know that first I would like to discuss the observations in hysteresis losses. So we all know that what is the empirical formula for calculation of hysteresis loss is nothing but eta Bmax power x frequency into volume, and for silicon steel the value of x is nothing but 1.6. So during the operation of a transformer, this eta value and the volume of the core is constant. So from this, in this condition, the hysteresis loss is proportional to what? Bmax power x and the frequency. So we all know that what is the Vmax observation? Vmax, which is proportional to what? Voltage by frequency. Voltage by frequency. Then substitute this Vmax in this equation. So in that case, the hysteresis loss is proportional to Bmax. Bmax is nothing but what? V1 supply voltage by frequency power x into frequency, right? For x, which is equals to 1.6 for steel. Therefore the hysteresis loss is proportional to V1 power x and F power 1 minus x. Okay, therefore WH, which is equals to V1 power 1.6 and F power minus 0.6. So this is the formula to calculate hysteresis loss. So we have to deal the cases, different types of cases. So that is rated voltage, rated frequency, rated voltage less than frequency, rated frequency less than voltage, rated frequency more than voltage. So like that, for different cases we are going to observe what are the changes in hysteresis loss. So first I would like to discuss case 1. That is, what is the case 1? If V by F is constant, that is voltage by frequency ratio is constant. In that case, the hysteresis loss is proportional to frequency only. What is the empirical formula? We all know that Bmax power x into F. So if V by F is constant, obviously what is the value of Bmax, which is also constant? So this is constant, right? Therefore WH is proportional to frequency only, right? If the ratio of voltage by frequency is constant, the hysteresis loss is directly proportional to, depends only on frequency. This is the first case. Depends only on frequency if Bmax is constant. If constant, in that case only the hysteresis loss is proportional to frequency only. So in order to get clear cut idea, I would like to take one example. Example, for a rated voltage and frequency, for a rated voltage and frequency, the values of hysteresis loss, let us take 100 watts. So for a rated voltage and frequency, the hysteresis loss is nothing but 100 watts. If the voltage and frequency are reduced to half. Then what about hysteresis loss? Then what about hysteresis loss? This is the example. So for a rated voltage and frequency, the value of hysteresis loss is nothing but 100 watts. The given data is nothing but 100 watts. But the second case, the voltage and frequency are reduced to half. That is solution. What is the case one? Or first, not case one, just we have to write V1 is nothing but V rated, right? F1 is nothing but F rated given. And what about V2? V2 which is equals to V by 2. Like that, F2 should be equals to what? F by 2. So we have to check the B max, right? Which is proportional to V by F, right? Therefore, V1 by F1 should be equals to given data V1 by 2 by F1 by 2, which is equals to what? V by F only, which is equals to what? V max. So because these two are reduced to half only, in accordance with the voltage, the supply frequency is reduced. Therefore, the value of V max should be equals to constant, right? So V max is constant. In that case, WH is proportional to frequency only. Therefore W is proportional to frequency. Then what is the value of hysteresis loss? So from this, WH1 by WH2 should be equals to F1 by F2. So let us take F1 or rated, right? F1 is rated, no problem. So from this, the value should be equals to what? What are the component of hysteresis loss? This is 100 by WH2, which is equals to, this is rated by 1 by 2, right? So from this we are going to get the hysteresis loss should be equals to 50 watts. So like this, you have to calculate the value of hysteresis loss for this case. In any case, in accordance with the voltage, the supply frequency is also reduced to half. Obviously, the value of B max is nothing but what? Constant only. This is the case 1. Now we have to discuss the case 2. That is, what is the case 2? V by F is not constant. If the ratio of voltage and frequency is not constant, then what were the changes in hysteresis loss? Then the area enclosed within one hysteresis loop is not constant. This is the empirical formula, and we have derived this equation, right? Hysteresis loss is proportional to V1 power 1.6 and F power minus 0.6. So in order to eliminate this proportion, we have to introduce a constant W should be equals to A into V1 power 1.6 and F power minus 0.6. So for this example is, for V is equals to 200 volts and F is equals to 50 hertz. For V1 200 volts and F1 is 50 hertz, WH should be equals to 50 watts or 500 watts. Then for V1, which is equals to, let us take V2, 100 volts and F2 should be equals to 100 hertz. Then what are the hysteresis losses? So what is the observation here? V1 by F1 is what? 200 by 50. The ratio is nothing but 4. Like that, V2 by F2 is nothing but what? 100 by 100, which is equals to 1. So from this, what is the observation? V1 by F1, which is not equals to V2 by F2, which is not B max, not constant, right? We are going to get different values for this case, and For this case, obviously B max is not constant. Therefore, what is the relation between hysteresis loss and voltage? Therefore, WH1 by WH2 should be equals to, which is proportional to voltage, that is V1 by V2 power 1.6 into F1 by F2 power minus 0.6. Then substitute WH1 is what? So from this, WH1 is what? 500 by, we don't know, WH2, which is equals to V1 is what? 200 by 100 power 1.6, and F1 is what? 50 by 100 power minus 0.6. So from this you are going to get the value of WH2, some amount of losses we are going to get. So like this you are going to calculate the values of hysteresis loss for different values of voltage and frequency. This is about case 2. So what is case 3? In this case 3, V1 is constant but frequency is decreased, that is frequency is less than F rated. So we all know that from this equation, frequency is reduced, which is below the rated value. Obviously, what about the value of flux density, which is increases, right? Which is increases. Therefore, V, which is equals to constant. So always WH is proportional to frequency only. Depends on frequency only. What is the second case? Depends on, for the second case, depends on voltage and frequency. What is the reason? Because V by F is not constant. But in this case, third case is what? Voltage is constant, V is equals to V rated, but F is less than F rated. So V is constant, obviously WH is proportional to F power minus 0.6, that is, what is the empirical formula for this? Proportional to V1 power 1.6 and F power minus 0.6. Here the value of voltage is what? This is constant, right? Therefore, what about WH? Therefore, WH is proportional to F4 minus 0.6 only, right? That's why F4 minus 0.6. So by keeping applied voltage constant, if the frequency of operation is reduced in a transformer, then that hysteresis loss is increases, right? Therefore, the hysteresis loss is increases in this case. If what is the case? In this case, P equals to V rated, F less than F rated. In this case, what about hysteresis loss? Like that, V equals to V rated, F more than F rated. So from this, proportional to 1 by F power 0.6. In this, proportional to F power 0.6, right? Or F4 minus 0.6. Here the frequency is reduced. What about hysteresis loss? Increases. In this case, frequency is more value. Frequency is more value. Obviously, the hysteresis loss is decreases. Then go through these two cases. Okay. Next, fourth case is what? Voltage is reduced. That is V, which is less than V rated, and F, which is equals to constant. For this case, what is the formula? V is less than V rated. We all know that P max, WH is proportional to V1 power 1.6, right, by F power 0.6. Here the voltage is reduced. Voltage is reduced. Obviously, hysteresis loss is reduced, which is equals to constant only. Therefore, what about hysteresis loss, which is proportional to V1 power 1.6? Depends only on voltage, right? Depends only on voltage. Why not frequency? Because frequency is maintained as constant. Obviously WH is proportional to voltage. If the voltage value decreases, WH decreases. If it is increases, this is increases. Clear? Just go through these 4 cases once, you will have better idea about the concept. Next, coming to eddy current loss, this is the empirical formula for the eddy current loss, right? K into Bm square into F square T square. So here the value of Bm is nothing but what? From this should be equals to V by F. There, from this, what is the derivation? Eddy current loss should be equals to K is constant, so V by F whole square into F square T square. So which is equals to V square by F square into F square into T square. F square gets cancelled, therefore eddy current loss, which is equals to V square into T square, right? But during operation, what about thickness of the transformer? But during operation, T is equals to constant, right? Therefore eddy current loss is proportional to supply voltage square, right? Then first case, so during operation of the transformer, this is the case if V by F is constant. If V by F is constant, what will happen to eddy current loss? If V by F is constant, obviously, which is proportional to what? Frequency square, that is voltage, which is equals to what? B max is constant, right? So from this equation, if B max is constant, eddy current loss is proportional to only frequency square, right? Only frequency square, that is the case, only frequency square. So in order to eliminate this proportional, we have to introduce B, some constant. So what is iron loss? Iron loss should be equals to hysteresis loss plus eddy current loss, that is with respect to hysteresis loss, that is AF, with respect to eddy current loss BF square, that is iron loss. So this is the formula to calculate the component of iron loss. If hysteresis loss changes, obviously if hysteresis loss changes and eddy current loss changes, obviously there is a change in iron loss. Okay. Next, case 2. If V by F is not constant, that is V by F is not constant, V square by F square into F square into T square. Therefore, only the eddy current loss is proportional to V1 square. In this case, case 1, same like in case of hysteresis, depends only on frequency. Don't worry, we will going to solve very beautiful problems after the completion of this unit. Don't worry about it. So in this case, if V by F is not constant, depends only on voltage, right? So obviously, what about iron loss component? Hysteresis loss plus eddy current loss. This is the case, V power 1.6 plus F power minus 0.6 for hysteresis loss, and B into V1 square is nothing but eddy current loss. Next, case 3. If V is equals to V rated and F is less than F rated. So in this case, frequency is reduced, B max is increased. That's why B max is not constant. In that case, obviously eddy current loss is proportional to voltage only. Depends on voltage only. So if frequency V is V rated, F is F rated, so it is irrespective of frequency changes. So that's why eddy current loss is constant. This is very important case. So in a transformer, the transformer which is operated at rated voltage with reduced frequency, then what is the change in eddy current loss? That is, there is no change in eddy current loss. It's very important case. So what will happen to hysteresis loss? Frequency reduces, obviously WH is increases, right? This is the formula to calculate iron loss, summation of these two. Clear? This case is very important, just go through this. Only hysteresis loss is changes, but what about eddy current loss? Eddy current loss is constant. If frequency changes, eddy current loss is constant because it is proportional to square of the supply voltage. Next, case 4. F is equals to F rated and V which is less than V rated, right? So supply voltage is reduces but frequency is constant. Obviously B max is nothing but changes, reduces, directly proportional to supply voltage. Therefore eddy current loss is proportional to supply voltage. Here the supply voltage is reduced, obviously eddy current loss is also decreases. Clear? What about hysteresis loss? Supply voltages is less than rated voltage, obviously this hysteresis loss is also decreases. Clear? Therefore iron loss is proportional to V square only. So now I would like to explain very important point. Listen carefully. If V which is less than V rated and F which is equals to F rated, therefore frequency is constant, right? There is no change in the frequency, only the supply voltage is reduced to rated voltage. So in this case, this is a case 4, right? So from this case 4, V is reduced and F is constant. Obviously the hysteresis loss is what depends only on frequency, right? Listen carefully all of you. Therefore hysteresis loss is proportional to V1 power 1.6. Clear? Right? Frequency is constant, only the hysteresis loss is always proportional to supply voltage power 1.6. This is one. What about second one? What about eddy current loss? Which is proportional to V1 square, because frequency is constant. In this case eddy current loss is proportional to supply voltage square. So the summation of these two is nothing but what? Summation of these two is nothing but iron loss, which is equals to hysteresis loss plus eddy current loss, which is equals to V1 power 1.6, not like that. Now then I am going to make a change. So V1 power 1.6, which is approximately equals to V1 square, right? Approximately equals to V1 square. This is equals to what? V1 square. So V1 square plus V1 square. So Wi is proportional to what? Supply voltage square. This is very most important observation. So in this, if voltage is reduced to rated voltage or increased to rated voltage, or you can write this case also. What is that case? Voltage is changes simply, or V is more than V rated. But what about frequency? Frequency is constant. In that case, hysteresis loss is proportional to V1 power 1.6. This is approximately equal to V1 square. Like that, eddy current loss should be equal to V1 square. So the summation of these two is nothing but iron loss. Therefore iron loss should be proportional to supply voltage square. So iron loss depends only on supply voltage, right? So if the supply voltage changes, the iron loss component changes, but during normal operation of transformer there is no change in the supply voltage, right? Once we provide the supply voltage during normal operation of transformer, there is no change in the supply voltage. Obviously there is no change in the iron loss component. So this is the very important point, very very important point. What is that point? As iron loss depends on applied voltage and independent on load current. This loss can be treated as constant loss only, since applied voltage is constant during normal operation. Therefore, this iron loss can be treated as constant loss. Very, very, very important point. What is the point here? Iron loss, which is equals to constant loss. What is iron loss? WIRPI, constant loss. What is the reason? Since it is depends on square of the supply voltage. This is very most important. What about variable loss? Copper loss is nothing but variable loss. Copper loss is nothing but variable loss. Iron loss is nothing but what? Constant loss. These two points are very most important. Why this copper losses are variable losses? Because if load changes, load current changes, because copper loss is directly proportional to the square of the current. That's why copper loss also changes. Therefore, copper losses are nothing but variable losses. Then what about iron losses? Iron losses are purely depends on supply voltage sphere. During normal operation of transformer, there is no change in the supply voltage. That's why iron losses can be treated as constant losses. So in transformer, what are the constant losses? Iron losses. In transformer, what are the variable losses? Copper losses. This is the very most important point. Just go through these observations once again without any confusion. So this is the summary table for WH and WE. So we all know what is the first case? Voltage by frequency is constant, that is B max is equals to constant, right? Constant. So in that case, WH is proportional to frequency. In this case, W proportional to frequency square. So this is the summation of these two. So what is the second case? V max is not constant, that is voltage by frequency ratio is not constant. In that case, it is proportional to voltage and frequency, but coming to eddy current loss is which is proportional to square of the voltage, and this is the summation of these two. This third case, voltage is constant, V equals to V rated and F is less than F rated, or F is more than F rated. Go through this case also, right? If F less than F rated, hysteresis loss increases. For what case? For F less than F rated. This when hysteresis loss decreases, when F more than F rated. What about eddy current loss? Because this eddy current loss is proportional to V1 square only. This is very most important case. Already we had a discussion regarding this, right? But coming to the summation of these two. Fourth case is what? F is constant and F is constant, voltage is variable. Maybe it should be less than rated voltage or more than rated voltage. Coming to hysteresis loss decreases and eddy current loss is also decreased because it is dependent on voltage. This is also proportional to V1 power 1.6. That's why this is also decreases. If voltage decreases, it is decreases. If it is increases, this is increases. Right? Just go through these cases carefully. You will have very good conceptual questions regarding this concept. This concept is very most important for competitive examination purpose. Thank you.